So a very good morning to Doctor. So we are from Group 10. Our title of our case study is CUDA for GPU. And I'm ZHENG Ming, and my other teammates are ZHENG Ming and WEN. CUDA, Compute Unified Device Architecture. CUDA is a very powerful software platform that helps us to run our computer program faster. And it is often used in solve performance intensive problems such as crypto mining, video rendering, and machine learning. Okay, CUDA can be embedded onto hardware. Specifically, that is the NVIDIA graphic card. Okay, so CUDA enable to be software or embedded onto hardware is because that CUDA for GPU itself has a CPU, that is the processor, central processing unit. Okay, so generally processor is used for mathematical and logical calculation of computer and running codes. It allows communication between different parts of our computer components, but for multitasking, not really can be executed. Okay, this is because that in a CPU, one core can only handle one task at a time. So for the most modern CPU, we can get is 16 core. That means only 16 tasks can be executed one by one. Because of CPU is extremely fast, we can't really notice the task is executed one by one in sequence at a time. So we can see that CPU is very limited when running tasks in parallel. So for graphic cards, graphic processing unit GPU, in CUDA GPU, the graphic card enable us to display image on monitor. Oftenly, graphic cards have its own memory and processor, and it will help in run codes in parallel, also offloading the processors on CPU. Okay, for example, when doing activities such as playing games, remote control will pass the task will executed from remote control to the CPU, after that to the GPU, then only display on our monitor. But with having graphic cards, one step can be skipped, that is CPU. That means from the remote controller, straight away go to the GPU itself, then straight away show onto the monitor. So we can see that GPU are faster than CPU when running codes. So as talked earlier, okay, one core can only execute one task. So by most 16 core of a CPU can execute 16 tasks, but for GPU, it is extremely exaggeratingly much, that is 10,000 more cores than the CPU. So undoubtedly, it will run faster than CPU. Okay, so CUDA able to run tasks in parallel with less time and resource, and able to solve problem at once. And CUDA allow us to switch between CPU and GPU processing, and this enable us to gain much more control of the task we want to be executed. For the features of CUDA, so there is thread identity. So thread is actually a parallel processor that computes floating point max calculation in an NVIDIA GPU, and thread blocks is actually a group of threads that can be executed together in series or parallel, and the kernel grids are a group of threads blocked on the same kernel. So for other features such as memory hierarchy, we have global memory, that is memory that resides in the device DRAM, and shared memory is on-chip memory that is shared within thread blocks. Local memory only exists for the lifetime of the thread and handled automatically by the compiler itself. Constant and texture memory is the read-only memory spaces that accessible by all of the threads. Multithreading. Multithreading is the model of program execution that allows multiple threads to be created. After that, in the process itself, it able to execute independently but concurrently sharing the process resources. Okay. Multitrading aims in improving the throughput of the tasks happening in the system, resulting to give us a better performance. In a thread, if a cache is missed, an attempt to read or write back the data in the cache will cause us to have a longer latency. So the other threads can handle the task using the unused computing resources. And by doing so, this will let us to have a faster overall execution, making a shift from the idle state. In CUDA, the kernel is executed with the aid of threads. Multi-threaded applications use many are running at the same time. It able to organize parallel computations.
Hi, I'm Hijame. So I will continue our presentation. So for the programming abilities for CUDA, the CUDA is can used in computer game industry. GPUs is used for graphic rendering and also used for game physics calculations. Besides, CUDA is used for non-graphical application. Moreover, CUDA is also provide both low-level API and higher-level API applications. Okay. Next is for the processing flow of CUDA. So at first, it copies data from memory to GPU memory. Second, CPU instructs the processing. CPU initiates the GPU compute kernel. Third, GPU CUDA's co-execute the kernel in parallel. And fourth, copy the resulting data from GPU memory to memory. Okay. Next is the advantage of CUDA. Okay. The first advantage of CUDA is scatter reads. In CUDA, multiple blocks are read into database block buffer that are scattered throughout memory. Scatter reads codes can be read from any address in memory. Next, CUDA is unified virtual memory, a single memory address space that is accessible from any GPU or CPU in a system. Besides that, shared memory. Shared memory is a powerful feature for writing well-optimized CUDA code. Access to shared memory is much more faster than global memory access because it is located on chip. Therefore, shared memory is also one of the advantages of CUDA. Moreover, CUDA has the advantage of faster downloads and readbacks to and from the GPU. CUDA improves performance on downloads and reads. Therefore, it works well in to the GPU and from the GPU. Last and not least, CUDA is full support for integer and bitwise operations, including integer texture lookups. That's all from my presentation. Next, I will pass to my members. Thank you.
So next is the limitation of CUDA. First, performance hit may occur when copying between host and device memory. Second, interoperability with rendering language. CUDA has one-way interoperability with rendering language like OpenCL. OpenCL can access the CUDA register memory, but CUDA cannot access OpenCL memory. Third, no emulator or fallback functionality is available. Fourth, valid C++ may sometimes be flagged and prevent compilation C++ runtime type information (RTTI) and C++ style exception handling not in debug code. So next is the application of CUDA. CUDA has been adopted in many areas that needs high floating point computing performance, such as bioinformatics, computational chemistry, computational science, computational fluid dynamics, computational structural mechanics, data science, defense, electric design automation, imaging and computer vision, machine learning, medical imaging, numerical analytics, weather and climate. CUDA accelerates rendering of 3D graphics, accelerate intercondition of video file format, accelerate encryption, decryption, and compressions. CUDA can be used in neural network training in machine learning problems and used in face recognition systems.
As a conclusion, CUDA implementation in GPU is very useful, especially in running tasks in parallel with a shorter time. The ability of CUDA to switch between CPU and GPU processing for specific tasks give us much more control and enable us to have a higher work performance. With CUDA's multi-threading, we can get a better performance. Its unused computing resource can be utilized to compensate for the missed read or write of a thread, and it able to overall boost the execution of the program. CUDA is a very useful in computer game industry and also in non-graphical applications. Yeah. So that is all from us, and thank you so much.